So for set 15F, we're assuming that the same guy who was driving the 60 km per hour car is driving now at 55 kilometers per hour. So when they're talking about independent, the acceleration being independent and the reaction time being independent, what they mean by that as independent of speed is that whether or not he's traveling at 40 kilometers per hour or 30 kilometers per hour, he's still going to have the same deceleration and he's still going to have the same reaction time. So from the previous questions, we know that his reaction time is 0.5 seconds, and we know that his deceleration is negative 3.704 meters per second squared. So that's what we calculated in part C. So once we have these, we can use our Suvat equation. So S is equal to ut plus half at squared, and v squared is equal to u squared plus 2as. So we want to find the stopping time and distance. So that's our main objective. So first, we have to calculate the time it took for him to react in order to find the total time it took for him to stop. And we also find the total time it took for him, the total distance it took for him to react. So he was traveling at 55 kilometers per hour, which is also 55 on 3.6 meters per second. And it took him 0.5 seconds to react. So we want to find that distance that he took before he stepped on the brakes. So using the equation, v is equal to s on t, and then switch it around, s is equal to v dot t. So substituting the two values in, it gives you an answer of 7.64 meters. So now we know our reaction distance. So I'm going to name this RD, reaction distance. We also know our reaction time. So time was 0.5 seconds. So reaction time, RT. Now we have to calculate our braking distance and our braking time. So we know our deceleration, negative 3.704 meters per second squared. Now we can substitute it into one of these two equations to find distance and time. So to find distance first, v squared is equal to u squared plus 2as. Rearrange the equation to make s the subject. V squared take u squared all over 2a. Substitute in all of these values. So v squared is 0 because you want it to come to a stop. And u is 55 kilometers per hour. 55 divided by 3.6 for meters per second. So it'll be 0 minus 55 on 3.6 squared on 2 times negative 3.704. That gives you an answer of 31 meters. So this is your braking distance. Now you want to find your braking time. So to find your braking time, you use the equation s is equal to ut plus half at squared. Now substitute s in, which we found from here. So 31 is equal to u, 55 on 3.6 t, plus half negative 3.704 t squared. Solve for t. You should get two answers if you're doing it the quadratic way, but take the positive answer. So the positive answer would be 4.13 seconds. So that is your braking time. Now what they want is the stopping time and the stopping distance. So the stopping time would be the total time it took during his reaction and during his braking time, and then the total distance would be the time it took, the distance it took for him to react and then brake. So total time Also stopping time is equal to 4.13 plus 0.5 gives you an answer of 4.63 seconds. And then stopping distance, you do the exact same thing, 7.64 plus 31 gives you 39 meters roughly. So these are the two answers for question 10F.